Hello everybody, I wish you're doing well. Welcome to my channel and welcome to my new video. Today we are here to machine a new workpiece called flats that we can find here directly. In examples, we can search for it and we will find it directly here. We'll open it, we'll see the workpiece as it is. So I choose this workpiece to use a new toolpath called, I think, flats also. That is a finishing toolpath that is here, raster flat finishing. So we will start by creating the box with global transform. We'll create it, we will accept, we will create a work plane, if you wish, aligned with the geometry or positioned in the block. We will position it just here. Then we will create a tool, end mill tool. So we'll put 16 end mill tool, 18 with a shank and a holder. We will add a holder, a part of this holder, the upper part. This is it. That is an HSK 63. We'll put the overhang of 18 or maybe more, maybe 120, 120. Sorry. And now we will create a model area clearance toolpath. We'll put a thickness of 0.5, step over of 5, and a step down of 5. We will choose a spire. We can do spirals here, I think, but we'll let it like this. We'll put step cut in and put some leading as ramp to not have the problem of the ramp. So if we don't have a ramp, so we will have the toolpath that enters directly. So we will do a ramp, and the links we'll let it in scheme, but we just take this, remove, sorry. Then we will simulate this toolpath. We'll see what will happen. Then now we checked here for collision. We see if there was issues. There is no issue. You can check for anything here, but for me it is not really important since we are doing just cam. But if you are going to do it in machine, it is better if you select this and this. So we'll do a new toolpath that is model rest area clearance with the same thickness of step over of 2 here and the step over of 2 also here. Invalid reference for restaurant. We didn't choose the rest, so we choose the toolpath number 1 that is here. So we have this. Let's simulate it with small speed. And then now we'll do our objective, that is sorry, that is doing the finishing. But before this, I want to create a small end mill of 8. Something like this. Then we'll have lower diameter, upper diameter of 20, and the HSK 63, that is 63, and 26 here. And we'll put it in 90. Here we set this, and here 19. And we will close it, and we will create our raster flat finishing. All triangles, so we let all this like this, and use the second and the tool path, use and calculate. So it will do all this. So let's simulate it. As you see, it is doing just straight lines. Sorry. So now we will create the stock model. We'll click on accept. Then we will bring all this the stock model, then we will calculate to see what we will have. So here in the first step and in the last step we will have this, but there is something you have to finish also these corners. So to finish these corners we have to measure them first. So we have a diameter of 10. We'll create a ball-nosed tool. Put it on 10. That doesn't matter. But the length of this doesn't matter too. And we'll create of 13. Here we will add so now we will do a corner finishing. I like to do it with this. So for horizontals it will be done in this sense, for verticals in this one. So step over of 2, depth of cut of 2 to here, put it into also to here. It will take time to have it, but we will have a good corner finish. The reference tool will be second, since it is the last that we use it. So now we wait for a simulation. Calculated and simulation, yes. Sorry, I do some weird sounds because I'm ill, so sorry for this. So this is it. Here I don't like it. uh, so I said that I don't like it, so what I will do is to create links, not scheme, but circular arc and circular arc here to have better ones here. So here what we will have this for all this. And why do we have all this? Don't understand. So we'll re-put it in scheme because we have, and put lead-ins here in none, and links here, put it in scheme, here in scheme, and calculate like this. We wish we have a better result. So I also don't like it. Maybe it is the reference tool. It is a toolpath that take so much times to be calculated. So we have a better toolpath here. Not a really good one, but we can say that it is better. We can have a better one, but let's just let it like this. Maybe with changing the tool, but let's just see what it will do. This part is not good. These are useless. We can just delete them by selecting them and clicking in delete. This is the magic of PowerMill. It is, and this is a pretty good toolpath. So this is it. So we can add it into this, calculate. So this is the rest material. And now we can create an NC program. Can choose folder. Let's just put it here and name it to 23, 23, and no machine tool. Work plane, output work plane. We put this one where automatic. And now I have the same problem, but I can open it from architecture here. Edit selected here, and automatic tools accept. What we also can do in PowerMill, we can directly simulate all toolpaths, but to see them, we have to open all the tools. We can see the machine indirectly. So here what we will have. Put more speed. So here's second toolpath. Here it have detected the collision, but let's just see it. It is a small collision with here. It we don't. Uh, it is a big problem, but there is some method to resolve it that we will see in the next videos. These problems can be solved with, for example, with editing the toolpath. As I told you, it was not a really good toolpath. This corner finishing. It would be better if we do it with another way and changing some parameters. I think the parameters to change are step over and depth of cut in either this and this, because it is doing us some problems. So here it is what we will have. So we'll have good finishing here. Yes, but we have some angles here, so we can't have good finishing, but we can do a toolpath of finishing to have a better surface here. So we can write the program. Yes, we forgot to choose the post. Finic. I will choose a Finic post processor and accept here. Let's write it. Here is the program. Here is the program that we can directly put in machine. Thank you for watching this video.